Okay, let's begin. So hi everybody, it's a pleasure to be there to share with you the experience we have with OpenNMS in a quite special context. I will try to explain you how our product works, and then I will go more deeply in the technical part. So, yeah, maybe first of all, I'm Pierre Tinglier. I come from RIMS Products, and I'm the operation manager and also developer. And you will see RIMS is, in fact, Remote Infrastructure Management System. A product from the Swisscom company is the Swiss company for telecommunication, and more. Now we have a lot of IT products. So what is RIMS? RIMS is a product for companies, small, large, every companies. The problem was for some companies to outsource the IT, but they don't want to outsource physically. So we had to create a product to give the opportunity to the customer to outsource the IT, but not physically, just the management of the IT. So for that, we need providers. We have now providers for Windows system, Linux system, DB system, and so on. And for those two parts, we provide a secure connectivity. We provide alarming tools, incident and ticketing tools. Everything is homemade. And so we give this opportunity to the customer to be linked to providers. The providers, what want a provider? They want management tools. We did it. They want security and firewall to access to the customer. We did it. And everything is secure. The customer, the needs and the benefits. So, as I said, the customer has several components in this company. He wants to be managed. He wants also the availability from his service and support. And they don't want to have personnel for that, too expensive, or they don't have the know-how. The benefits with us, it's flexible and dynamic infrastructure. Everything is like a module. You can add functionality, you can subtract functionality. And the profits is also connected to a large amount of providers. So you don't have to look for the providers. We connect him to the providers. The provider's benefits, as I said before, he has the connectivity and some tools, or when the tools doesn't be okay for him, we also have APIs, and we give the opportunity to the provider to connect to our APIs, or when he is not be able to do that, we are also able to do that for him. Welcome to the marketplace. We have customers on a side and provider in another side. Every customer has different needs. So maybe this one has more database to monitor, and Linux system. This one has more Windows system and fronted, websites, or I don't know. This was a DB, but it's a Postgres DB, and this one was an Oracle DB. Okay, they are all another need. And the other side, we have provider. Maybe a provider can do anything for a customer. So in that case, the provider A can do everything for the customer 4. Let's say he's able to monitor and to manage the Oracle DB and a website. So we will give to this customer a provider A. The provider C is good for apart from the IT park from the customer 2 and the customer 3. So it will be connected to these two customers and it will manage not all the server from these two customers, but only at 10 ports. For the customer 1, the provider B is the best, so it will do everything. So now, we have to do a platform where the customer and the provider can be talk with each other and can access. So I think more in that way. So the provider go on the server from the customers. What it say? So the customer has his IT infrastructure. The provider has also his IT infrastructure with the worker. And our product is so. We build a virtual area on our platform with tools, some tools. And in definitive, that's just a stretch from the network. So for the customer, is the same IPs. He is connected through VPN. So it's his own infrastructure there, but with our systems. For the provider, it's the same. He has also a stretch from his network. And in our system, we give the access through the firewall to give the opportunity to this provider. He can access to his area because it's a stretch from his network. And he can access to the customer area or to the customer's area. And after that, when he's here, it's a stretch. So he's here and he can manage the server. What we have in this area? So we have CMDB, where we have all the contractual data, all information for the nodes, the configuration items, and so on. We have an OpenNMS for the monitoring part. And we have Windows jumps and Linux jumps to give the opportunity to the provider to be connected to his area and after to go to the customers. And for the firewall, we use pfSense technology because it's open source. For us, that's the leitmotif. We want to use open source. So the RIMS product. We have areas, open source, almost open source because of the Windows. Nobody's perfect, but we have to. And OpenNMS, open source, pfSense, open source, and the CMDB is a homemade solution. So we developed our own CMDB to to fit to the best with the whole architecture. Maybe there are providers or customers, they want to use other tools. I mean, in particular for the ticketing incidents. They want to use maybe a BMC solution or I don't know what. So we build APIs for that, and they can they come to us through the API, and they catch the events, they catch the incidents. Or we can make a partnership and say, okay, here on this API you can build something to get, but we will build API to go to your APIs for the push solution. As I said, that's the architecture for the customer and providers, but we don't have only one customer. So once again, the components, we have more customer. And let's say what? Let's say we don't only use one OpenNMS. Every single customer and every single provider has his own OpenNMS and his own jumps and his own pfSense and his own CMDB. So it's a bit different in our product because we have to manage more than one OpenNMS. Why that? It's simple because, as I said, it's a stretch from the network. So it's possible there is twice the same IP. The OpenNMS, it's the same interface, but no, it's totally another thing. Okay, enough business, let's go to the techno. So, to do everything, also every part of our product can talk with another part. We choose to use the RabbitMQ protocol and service. Our own CMDB is developed with Ruby on Rails. We love that because it's very quick to develop, and we can, every 2 weeks, a new release, easy to deploy. It's perfect for us. And so, because we like Ruby, we build a kind of tiny module which will be dialogue with OpenNMS in our case, and also with pfSense. We are automatically generating configurations to make possible the routing for a provider to the different customers. And that's the main goal for us. It's to be able to talk Chinese to an Italian guy and he understands. Not so easy. So if we go a bit more up, we have this RabbitMQ server, one on every single area, and in each area, the servers, the services, will talk with each other and to send message to the queue on the server and get the message on the RabbitMQ server. And after that, we have to synchronize the information, because when a contract is for a customer, the information relative for a provider will be synchronized to the provider. So everything is automatic. Okay, I come back closer to the module, the teeny module. So we use Ruby, I said. We use Thin and Sinatra. What is that? Thin and Sinatra gave us the opportunity to build a lightweight web server, so we can create API, REST API, and we can also, in the other part, talk to the APIs from a product. So as we can do with the OpenNMS, we can configure the OpenNMS to send the notification to a REST API. So we did it. And to configure the requisitions, an example, we can do that through the REST API from the OpenNMS. So this tiny module received the information from the CMDB. It translated to OpenNMS language, and it will be able to create the requisitions. But what are our interactions with the OpenNMS? It's a fact we don't use the whole OpenNMS. For us, what is important is to create requisition and to receive the event. The requisition, it's okay, we use the API. But for the event, it wasn't so perfect for us because we didn't have the perfect granularity on the event. So we did that. We have the OpenNMS, and we have our tiny module. We are creating the requisition through the REST API. But oh, what that? The DB. When an event is created, or an outage after the event, we had configured the DB to send it to the module. Or I will say the module is listening on the DB, and when an event is created, it will take the information we need and send it to the CMDB, and on the CMDB, it will be generate an alert or forward to the right provider or to the right providers, because for a service or for a node, it could be managed by different providers. In example, we have on a node a web server and a DB on the same node. But the DB is the provider A, and the web server is the provider C. And we have to keep the information inside the area. So inside the area from the customer and from the provider A and B. The event will be created, forwards to the CMDB from the customer, and then it will be synchronized to the provider A and to the provider C. Maybe the provider A will have the information when the node is down as an information, not as an alert, because it's not his job, but it's important for him. And the provider B wants to know when the node is down because he's scared about that. So in the configuration in the CMDB, the provider A can choose, okay, for this event, for me it's just an information, and the provider C will configure, oh, it's an alert. So I come back to this event, it comes to the customer, it goes to the provider A, it will send a mail information mail, and to the provider B, it will send an alert. How we did that? We created in our module a functionality to create function on the DB, so in Oracle, in Postgres, sorry. It creates a trigger too, and then it will listen to a procedure, and this procedure will be called when the trigger create or an update. So, what it means? For us, notification escalation path, unfortunately, we don't use. But it doesn't match with our system. So it's live. Maybe another interactions, another interaction we do with the OpenNMS. In the CMDB, we created templates. An example, in the template A, it's an ICMP only. In the template C, it's ICMP and SNMP. In template C is the only HTTP monitoring service. Okay. So we choose for the node A, we want to have the ICMP and the SNMP. So we applied these two templates. For the node B, the SNMP, and for the node C, the web monitoring. We mix up all that, and through the REST API, we're creating the requisition in the OpenNMS. I think I'm a bit shorter than it was written, but I thank you all for your attention, and if you have questions, do not hesitate. I'm here and glad to answer it.
Why did you choose to access the database directly?
Sorry?
Why did you choose to access the database directly instead of using, like saying, to OpenNMS, just forward all events to our system?
It's because we use in the CMDB to not send everything to the providers. Only 5 minutes after we are sure the event is a done event, for example. And for that, it was easier to configure everything in the CMDB. And through the OpenNMS, we only can forward the notifications. And we cannot manage this 5 minutes or this 2 minutes directly in the OpenNMS through an API. I don't know if it's answer to the question.
Okay. And how do you manage the installation of OpenNMS when you set up a new environment? How does that work?
The installation of the OpenNMS is doing through the Ansible and Puppet Master. So we combine the two, and we have a template. And to the Puppet Master, we can configure the base. And after it, when the contract is okay, we can configure for all nodes what we want to monitor, and after that we synchronize to the OpenNMS, and it creates automatically the requisition unit.
So is OpenNMS in your various separate instances, is that for them monitoring their systems, or is that for monitoring just inside those separate areas, as it were?
So the OpenNMS in the area, it's to monitor the infrastructure from the customer, so the distant infrastructure. Right. We also use an OpenNMS to monitor the whole infrastructure, of course.
Makes sense. Yeah. So it sounds like you created your own provisioning system.
Mm-hmm. Mm-hmm. I understand. The main reason is for us, we want to push the information to the OpenNMS. And with the system, you said it hold the information towards the DB and it take it, right? So as I said, in our product, everything is a module. So in the first version, we had another system for the event bus. It was not Rabbit, but it was so modular. We taking off and we put Rabbit instead, and it worked with so a minimal effort to replace it. And it's a decision from the management to to do.
Right, yeah,
But it's not so bad, because with this solution, when we want to change the percent, because it's no more okay for us. It's the functionality are not so good for us. We want something else. We can just change it. Yeah. And of course, it's the same for the OpenNMS. For the moment, it's the best application for us. It's what answers best to our problems. But it's also in this way, when we want to take another application, we are able to do it with a minimum effort. Okay. Any questions? No. So thank you very much, and have a nice day, and everything good for the future.
Thank you.
Thank you.